Here we see a close-up of the iron-carbon system that is at the lower carbon concentrations and in the temperature around 727 degrees. And here we can recognize a part of the phase diagram that looks like the eutectic we talked about before. But the important difference here is that this is not a liquid, this is a solid phase. And this solid phase will transform into two other solid phases when we go down under this line. So here we have a two-phase region with alpha and cementite. Here we have a one-phase region with only gamma or austenite. So if we look here at this exact composition, which is about 0.8% carbon, we will have from the beginning austenite phase. We will have some grain boundaries, but it is a solid phase. And when we pass this point, we're going to have these two phases, alpha and cementite. And that will occur in a similar way as in the eutectic system, as these two phases are going to cooperate when they are growing. Here schematically it have been drawn that there are some lamellas of the two phases, cementite and alpha. And we will look closer into that, how these phases are growing, and also look at some real structure pictures. Here we see this lamella structure growing into the austenite grains. We see that there are lamella of ferrite and cementite growing parallel into the austenite grain here. This type of structure has its own name. It has a specific name, and that's pearlite, which is important to remember. It's an important structure feature in steel. And two things we have to point out here. One thing is, why is it growing like lamellas like this? Well, what is going on here is that carbon has to be distributed between these two phases. We know that ferrite does not solve nearly any carbon at all, while the cementite compound here contains about 6.7% carbon. So carbon has to diffuse from these areas ahead of the ferrite lamella to the point here where the cementite is growing. So we have a redistribution of carbon all the time going on. And it makes it very short diffusion distances if the structure is formed in this way, that lamellas are growing like that. Another feature is, where does it grow? Well, this is a grain boundary between two austenite grains, which we had from the beginning, and it's very likely that you get a precipitation of the new phases in the grain boundary, because there is a disturbance in the structure, and it's energetically favorable for new phases to form in that disturbance, because it lowers the total system's energy. And then when it has formed here, it will grow into one grain, and also sooner or later it might nucleate somewhere in the other grain and grow into that one. So now we can look at the real structures from the microscope. And here we see a structure with a low magnification in a low carbon steel. This is not a pure pearlitic structure, it consists of both ferrite and pearlite, but we will focus on the pearlite here. And if we increase the magnification, we see these brown-gray areas, that is the pearlite, and the white is the ferrite. And even at high magnifications, we see a little bit better the typical appearances of the pearlite. And we will focus on one area and look for a while at that point. And here we clearly see then what is the pearlite area. And you can also see that the brown-grayish appearance, and some areas also are darker, and here it becomes more gray, and here they have a lighter area. And in this lighter area we might imagine that it might be some lamellar structures, but we need to go to a higher magnification to see the lamellas, to resolve each lamella. So we increase the magnification one step. Here maybe we see a little bit better that it is a lamellar structure in some areas in the center here, but we will still increase the magnification, and here we see the same area as before, and here we actually see the lamellas, but we will stop here at an even higher magnification, and here we see clearly that it's a lamellar structure in this region, and we can see the dark lines here, which are the cementite phase, and the white areas in between is the ferrite phase. In this region here, the cut has been nearly parallel to the lamella. That's why we can see them so clearly. While in the area to the right, it's rather dark, and here the cut has been perpendicular to the lamella. And this is the typical for the pearlitic structure as you see it in the microscope, the different areas cut in different ways.